Welcome everyone to ExamBees tutorial. I have received few requests for doing a video tutorial on dimension analysis. And this is what I'm going to talk about in this video. This lecture has been prepared keeping in view of the audience who are not from science background. Dimension is all about units of physical quantities. In fact, in our daily life we use it so much that we often ignore its importance. For example, this car is moving at a speed of 100 km per hour. Here the speed is a physical quantity and we associate a unit called kilometer per hour. It could happily have been kilometer per second or meter per second or centimeter per hour. Anyway, in all of these units, the fundamental meaning is same. That is, for every case, it is length per unit time. Without any difficulty, we understand what 1 liter of water is. It refers to the volume of bottle in which water is contained. Here the unit of volume is liter. It is also expressed as cc or centimeter cube. If it is a rectangular box, then the volume is length time breadth time height. If it is a cylinder, then it is pi r square h. If it is a sphere, then it is 4/3 pi r cube. Again, if you look carefully, in all of these cases dimensions are length times length times length, which is equal to L cube. Let us take another example. When we go for buying a house or an apartment, we want to know its carpet area. We appreciate if the seller tells us in square feet or meter square. It is area we are talking about, so its dimension is L square. Do you recall any other physical quantity? What about density? Density gives us a sense of how dense a material is. How much volume is it needed to accommodate its mass? This is also a physical quantity. And how do you express this? We generally tell it as gram per cc, kg per meter cube. However we express the unit, its dimension is mass over length cube. So far, we have learned 4 physical quantities. They are speed, volume, area, and density. Using L, T, and M, we have constructed these physical quantities that we frequently use in our daily life. These L, T, and M are the most fundamental dimensions, and using them in different combinations, we can produce other meaningful complex physical quantities. Yes, you have guessed them right. They are energy, power, pressure, momentum, force, acceleration, frequency, and lots of other things. In physics, apart from L, T, and M, 2 more dimensions are used. They are charge and temperature. Sometimes just velocity is not enough for describing motion of an object, especially when velocity is changing itself. We need additional quantity like acceleration, which denotes rate at which velocity is changing or its change in velocity in unit time, which is given by v over t. The dimension of acceleration can be written as v over t, or which is equal to lt to the power minus 1 over t, which is again can be written as lt to the power minus 2. Do you know there is also another term called jerk, which is the rate of change of acceleration? We experienced this while sitting in a car when gas pedal is pushed while the car was already accelerating. The car will transit from one accelerating state to another. This change in acceleration is called jerk. So jerk equal to acceleration over time. This is because there is a change in acceleration in unit time. So this can be written as L t to the power minus 2 over t, which is equal to L t to the power minus 3. Now let us talk a little bit about force. Well, force is defined as an interaction that causes any object to change its velocity or just accelerate. If the magnitude of the interacting force is 0, the object remains in a constant motion or at a state of rest. Remember, force is a vector quantity, has both magnitude as well as direction. Force is expressed as mass times acceleration. It is also expressed as rate of change of momentum. Now let us do a dimension analysis of force. So one thing is very clear. The dimension of the left hand side should be equal to dimension of the right hand side. And the dimension of the right hand side can be broken into 2 parts. One is the dimension of m, which is just capital M, and the dimension of acceleration, which is just Lt to the power minus 2. So finally, the dimension of F is equal to mLt to the power minus 2. The next question that we want to ask is, what is the unit of force? We'll try to answer this question from the dimension of force. We have already learned dimension of force is mLt to the power minus 2. Now, in MKS system or SI system, this ml and t translates to kg, meter and second respectively. So the unit will be kg meter per second square, and 1 kg meter per second square is just 1 Newton. Now let us explore how this unit changes in CGS system. Well, this is fairly a simple problem because 1 kg is just equal to 1000 gram and 1 meter is 100 centimeter, and the time unit is same in both the system. So let us substitute this. So if we do this, then it becomes on the right hand side 1000 grams times 100 centimeter times centimeter per second square. So this is equivalent to 10 to the power 5 times gram centimeter per second square, and gram per centimeter second square is equal to 1 dyne. So finally we get the answer, the relation between SI and CGS system, 1 Newton equal to 10 to the power 5 dyne. Another important physical quantity is work or energy. In physics, a force acting on a body is said to have done some work when it causes a displacement along the direction of force, and mathematically work is expressed as force times distance. Now let us ask the same question as we have already asked before. What is the unit of work? In order to answer this question, we will play the same game as we have already played in the case of force. So dimension of left hand side should be equal to dimension of right hand side, and dimension of right hand side is basically dimension of force times dimension of distance, which is equal to mass times acceleration times distance, which is mLt to the power minus 2 times L, which can be written as mL square t to the power minus 2. The second question that we want to ask is, what is the unit of work? Well, this is very simple to answer. All we have to do is to substitute units of corresponding dimensions. In SI system, unit of mass is kg, and there are 2 powers of length, so we will have meter square turn, and 2 inverse power in time, so we will have per second square. So 1 kg meter square per second square is defined as 1 joule, which is in SI system. Now when we want to convert this in CGS system, all we have to do is to substitute gram and centimeter in place of kg and meter. When we do this, we obtain 10 to the power 7 gram centimeter square per second square. 1 gram centimeter square per second square is defined as 1 erg. So 1 joule is equal to 10 to the power 7 erg. Okay, now let us talk a little bit about pressure. Indeed, pressure is one of the most common physical quantity that is frequently used not only in physics but also in our daily lives. For example, we often call about atmospheric pressure, tire pressure, blood pressure, or even cabin pressure. Well, in physics, the pressure is defined as the amount of force acting per unit area, which is just equal to force divided by area. Now we want to determine what is the dimension of pressure, and this is very simple, and we will play the same game as we have done before. The dimension of pressure is the dimension of force divided by dimension of area, and we already know how to determine the dimensions of these two quantities. So dimension of force is mass times acceleration, and area is just L square. So this together gives us mL t to the power minus 2 divided by L square, which is equal to mL to the power minus 1 t to the power minus 2. Now we want to ask, what is the unit of pressure? And the trick to determine the unit is to replace the dimension with its physical units. And here the mass will be replaced by kg, and L to the power minus 1 will be replaced as per meter, and t to the power minus 2 is just per second square. So the unit of pressure is kg per meter per second square. In SI unit, this quantity is just 1 Pascal. We can also look at the problem in slightly different way. Since we know the unit of force and area, the pressure can also be expressed as Newton per meter square. Can you guess how much is the atmospheric pressure at the sea level? Well, this is an amazingly big number. 1 atmospheric pressure is equal to 10 to the power 5 Pascal. Does this number make any sense to you? If you do a little calculation, it can be shown very easily that while you are having fun in the sea beach, your head is actually carrying a mass of about 240 kilograms. A little fun play with dimension, you can show different ways of expressing pressure. If you follow this step, you can easily show that pressure can be written as energy per unit volume or just energy density. Again, it can also be written as density times velocity square. What is the dimension of the gravitational constant g? In order to answer this question, we'll have to see how g is related to the force of gravity. Well, according to the Newton's law, the gravitational force of attraction between two bodies is directly proportional to the product of their masses and depends inversely squared of their separation. And the proportionality constant is the universal gravitational constant called g. So the dimension of the left-hand side should be equal to the dimension of the right-hand side. In fact, the dimension of g should be such that when we multiply m square over l square, it should give the dimension of force. And since we know already the dimension of force, the dimension of g can be written as mLg to the power minus 2 times l square over m square. So g is equal to m to the power minus 1 l cubed t to the power minus 2. Now, very interesting thing is that if you look carefully, the m to the power minus 1 times l cube is actually inverse of density. So g is also can be written as t to the power minus 2 over density. And here is an exercise for you. Can you show that 1 over square root of g times density has a dimension of time? Now let us do a couple of more exercises. If a force is linearly proportional to velocity and is given by F is equal to k times v, what is the dimension of k? The solution is given below. And here is the last exercise of the video tutorial. Energy of a photon is related to its frequency through E equal to h times nu, where nu is the frequency and h is known as the Planck constant. Then what is the dimension of h?